average value theorem. The average value theorem of a function from x equals to a to x equals to b is equals to this 1 over b minus a times the definite integral x goes from a to b f of x dx. So it's pretty simple. So you are taking the integral of the function f of x from a to b, and then you have to add one piece in front of that, that is 1 divided by b minus a. So I've just used a very simple example. So let's say f of x equals to 1/2 x squared. I want to find the average value of this function where x goes from 0 to 4. So the average value 1 over 4 minus 0, and then definite integral from 0 to 4 half x squared dx. So let's see what that equals to. So you see I have the answer written over here, but let's do the detail right now. All right, so 1 over 4, and then the antiderivative of the integrand, that is what is that equal to? That is equals to x to the third, right? So that is 4 multiplied, so this is a x to the third, and then 1/2 times 1/3 is equals to 1 over 6. So check your work really quick. Take the derivative of that, bring the 3 down, you will get back to the integrand very easily. And then this goes from 0 to 4, so you have 1 over 4 times 1 over 6. I will just keep the 1 over 4 right over here. I won't multiply the 1 over 4 in until the last step. So you have a 1 over 6, so you have a 4 to the third minus 4 to the 0. Let's see what that equals to. So 4 to the third is equals to 64. So you have a 1 over 4 times 64 divided by 6, and then this is a 1 over 4 times 32 over 3, and then this is equals to 8 over 3 after you reduce the fraction. So let's do some boxing. So this one is what? What is this? This is the average value, right? And then what about 32 over 3? 32 over 3 is the area under the curve, so this is area. Alright, so that's why I have this piece right over here. So let's take a look. We have a 1 over 4 times 32 over 3. This is the last step. That is equals to 8 over 3, approximately equals to 2 point a bunch of 6. So I just rounded up to 2.7, and 2.7 is the average value, and then the area under the curve is 32 over 3. So you did the work, right? So for the average value theorem, most people will say, all right, that is easy. All you have to do is 1 add a piece, 1 divided by upper minus lower in front of it. Yes, I know that is easy, and the integration is easy as well. What is the answer represent? So I want to interpret the average value 8 over 3. So let's bring the graph down here. So this is, do you see that there is a blue parabola? So the blue parabola represents, so I should put it down at the very beginning. So this is y equals to 1/2 x squared. That is the function. That is what the parabola represent. And I found the area from 0 to 4. Do you see that there is a yellow region? So what is the yellow region equals to? The yellow region is equals to 32 over 3. That is the area under the curve. And you also see that there is a y equals to 2.7, which is the average value. So this one I am going to do this, and then this is the average value. So what does that mean? You have 2.7, and I say that that is y equals to 2.7. So why is that a y equals to, not x equals to? So that is y equals to 7. So pay attention to this. The average value tells me where to cut the area horizontally. Again, the average value tells me where to cut the area horizontally. In this problem, that tells me cut the graph at y equals to 2.7. So I use an orange line to cut the curve at y equals to 7. So when I cut the curve at y equals to 7 from 0 to 4, and then the y is equals to 2.7, do we agree that we just have some sort of like a rectangle? right? So y is equals to 2.7, and then the base of the rectangle is 4 units long, and then the height is 2.7, or you can say the height is equals to 8.3. And then the area of this rectangle is 4 times 8.3, so you have a 32 over 3 that is approximately equals to 10.7, and then a 10.7 is the area of the rectangle. All right, and then the 10.7 is not only the area of the rectangle, but is also the area of the air. But it's also the area under the curve from 0 to 4. So let me say this one more time. The average value is equals to 2.7. I'm going to call that y equals to 2.7. That tells me that I should cut the area, so cut this region. Do you see the blue region in the first picture? I should cut the yellow, did I say blue region? Yellow region. So do you see that there is a yellow region in the first picture? All right, so the average value tells me, hey, you should cut the region at y equals to 2.7. All right, so I make a cut at y equals to 2.7. So y equals to 2.7, I got a line over here, and then the base is from 0 to 4. That is what I asked you to do, right? That is what a definite integral from 0 to 4. And then y is equals to 2.7, the base is equals to 2.4. So that gives me a rectangle where the base is equals to 4 and then the height is equals to 2.7, or in fraction 8.3. So the area of this rectangle is 4 times 8.3, which is 32 over 3, approximately equals to 10.7. Look at this 10.7 one more time. The 10.7 is actually the area under the parabola from 0 to 4. So we have the area under the parabola from 0 to 4 equals to the area of the rectangle. Do you see that? So that's why I said right here, area under the curve is equals to area of the rectangle. So that is the interpretation of the average value. It tells you where to cut the region horizontally such that the area of this rectangle is equals to the area under the curve from the lower to the upper limit. There is another way to interpret the average value. You have to look at the last picture right over here. Once again, 2.7 tells me that I should cut the graph at 2.7. And then do you see that after the cut, there is an empty region right over here, and then there is a little region above the 2.7. So the average value tells me that I can take this area. Do you see that fulfill the gap? I can take this area to fulfill the gap to get a rectangle. Once again, I cut the region horizontally at 2.7, and then I can use this piece to fulfill this gap, and then the area of this rectangle is equals to 10.7, which is equals to the area under the parabola from 0 to 4. And then there is another way to interpret that. When y is equals to 2.7, x is equals to right here, a little bit more than 2. Don't worry about what that is. If you cut this piece out and then you put an arrow right over there, this is the position to balance the area. Look, try to picture this in your mind. It's very easy. If I place an arrow right over here, follow my orange arrow, do we agree that the area will just tilt to the right? Is that correct? Can you picture that? Okay, one more. If I place an arrow right over here, do we agree that the area will tilt to the left because it is not balanced, right? Okay, so, and then last step, when I place an arrow right over here, that is the position where you can balance the area under the curve. So that is the third way to interpret the average value theorem. All right, so that is the end of this video. If you like it, give me a thumbs up, a subscribe, stay tuned, and I will see you all in the next video.